Hi there, Chargers. This is Mrs. Boyd. Today, we're going to be talking about the triangle inequality. First, let's start with the triangle inequality theorem. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So, if we're going to do AB plus BC, AB plus BC, that has to be greater than side AC. If we're going to do BC, ooh, the cat kicked me, sorry about that. BC plus CA, that has to be greater than side AB. And finally, if we have side CA plus side AB, that has to be longer than side CB. Let's do some practice with these. Determine whether the lengths given could be the sides of a triangle. Prove why that is true with one inequality. So what we're going to do here is add the two shortest sides together. 8 plus 10. That is 18, which is greater than 12. So yes, 8 plus 10 is greater than 12, and this could be a triangle. Now, we have 1 and 2 are the two smallest sides. 1 plus 2 is 3. Well, that's equal to 3, not greater than. So no, this could not be a triangle. Next, get my computer to cooperate. We've got 4 plus 5 as our two shortest sides. Well, that's 9. So 4 plus 5 is less than 10. So no, this cannot be a triangle. Our two shortest sides have to be greater than the longest side. Let's try another one. 5 and 7 are our two shortest sides, and that's 12. And 12 is less than 14. So yes, that could be a triangle. We've got 8 plus 9 is 17, and that's greater than 10. So that one's a yes. The one before, I told you very incorrectly. 8 plus 7, while yes, it is less than 14, since it's less, it's not yes, it's no. That has to be longer. So sorry about that. Next, I've got 2 plus 3 is 5, and that's less than 15. So no, not a triangle. Back on track. Whew. Got 11 plus 14 as our two shortest sides. So that's 25. And that's greater than 15. So yes, that's a triangle. We've got 4 plus 4. And that equals 8. Not greater than 8. So that one's no. Last one on this page. Got 3 plus 4 is our shortest sides, and that's 7, so that's greater than 5. So yes, that's definitely a triangle. Flip it over to the back, and oh lordy, that got big. We determine side range. All right, to determine the range of values of the third side of a triangle, set up two inequalities. So we have x plus 4 has to be greater than 9. If we're going to add AB and CB together, it has to be greater than 9. If we have 4 plus 9, AB plus AC, that has to be greater than x. So 4 plus 9 is 13. So 13 has to be greater than x. If we subtract 4 from each side here, we'll get x is greater than 5. So that makes the compound inequality that is our side range. 5 is on the low end, 13 is the high end, and x goes in the middle with all less than signs. Let's try some more of these. All right, so what we're going to do to determine this range is the next part. Determine the range of values for the third side of the triangle with the given sides. We're going to do very specific order here. We're going to do x plus the smaller number. So of the smaller numbers, I've got 8, and that has to be greater than the biggest number, 10. I can also, and I am also going to do 8 plus 10. Both the actual numbers that we have has to be greater than x. So we solve for each of these, subtract 8, and I get x is greater than 2. And we have 18 over here is greater than x. So our range is x is less, or 2 is less than x is less than 18. Same idea, smaller number plus x. So x plus 1 has to be greater than 2. And add these together. 2 plus 1 has to be greater than x. Well, we solve for x here, subtract 1 from each side, and I get x is greater than 1. And I add them together on the bottom one, and I get 3. So my range is 1 is less than x is less than 3. Getting the drift. So again, we're going to do x plus the smaller number is greater than the bigger number, and the little number plus the big number is greater than x. So we solve here, subtract 4, and we get x is greater than 1. Add here, 9 is greater than x. We flip it around and we get 1 less than x less than 9. Let's do some more. X plus small number is greater than big number. And little number plus big number is greater than x. So we subtract 5, we get x is greater than 9, and we add them together and get 19 is greater than x. So our range x, or 9 less than x less than 19. Let's do another one. X plus the smaller number, 8, is greater than the bigger number, and add them together, and that's greater than x. So we solve, and we get x is greater than 1, and add 17 is greater than x. So our range, 1 less than x less than 17. X plus the little number is greater than 3, and 2 plus 3 is greater than x. We solve here, x is greater than 1, and add 5 is greater than x. So we get 1 less than x less than 5. Just a few more. So these are the same number. So we'll do x. It doesn't matter which one we put with the x because it's going to give us the same thing. And then 4 plus 4 is greater than x. So we subtract 4, and x is greater than 0. We add these together. 8 is greater than x, so our range is 0 less than x less than 8. Just a few more. If you haven't tried any on your own by now, now's the time. We have x plus 14 is greater than 15, and 14 plus 15 is greater than x. We simplify, we get x is greater than 1, combine like terms, 19 is greater than x, so we've got x in the center, 1 and 19 on either end. See if I can get my computer here to work. Here we go. So x plus the smaller number is greater than the bigger one, and add them together, and that's bigger than x. So simplify, minus 4.2 on either side. That gives us x is greater than 2.9, and add them together, and we get 11.3. It's greater than x. So 2.9 less than x less than 11.3. Whew, that's a lot of work. But maybe doing this same repetition all of those times will help you to better understand and remember what it is you're supposed to do. I hope these make all sorts of sense to you. I hope you reach out if you have any questions, and I look forward to seeing you soon.